and microwave, VLSI design, and machine learning with a PhD in antennas and wave propagation. He is currently associated with the Department of Optoelectronic Engineering at National Formosa University, Taiwan. Dr. Shanmugh
Recording in progress.
actively engaged in real-time product development for cutting-edge R&D projects tailored to the UK market. With over a decade of experience in academia and research, he has made significant contributions in antenna design, IoT solutions, and machine learning applications, particularly in healthcare and communication systems. His expertise spans microwave devices, VLSI technologies, and advanced machine learning integration. As a senior member of IEEE and an active participant in IEEE Antennas and Propagation Society, Dr. Shanmusundaram has an impressive portfolio of achievements, including a granted patent for a metamaterial inspired antenna design and numerous publications in leading journals and conferences. He has also led international collaborations and mentored students to foster innovation and academic excellence. So, I welcome you, sir, to the session to give us some insights about the future trends in AI and healthcare. And welcome you, sir, to the session. Sir, your screen is visible, sir. You can take over the session. Participant, this is
Yeah,
the second
yeah. Thank you.
voice is also audible, sir.
Yes,
You
yes.
can
Am I
take
audible?
over. Yes, sir. Yes.
Yeah, thank you, everyone. Uh, Myself, Dr. Shanmugh Sundaram, and it's a pleasure to be here with such a distinguished group of faculty from across various institutions. Today, we will be exploring future trends in AI and healthcare, emerging technologies, and their potential impact. Over the next 1.5 hours, we will delve into how artificial intelligence is reshaping every factor of healthcare from distant diagnostic and treatment to research and administrative operations. I am excited to share some of the most advanced example and the latest developments in our field. So here a brief roadmap of our session today. We will start with an introduction to AI and its evolving role in healthcare. Next, we will examine emerging AI technologies with cutting-edge examples from deep learning breakthroughs in radiology to how AI-driven genomics. We will then cover how these innovations are revolutionizing clinical diagnosis, treatment planning, and operational efficiency. Flowing that we will discuss challenges including ethical, legal, and regulatory issues, and wrap up with a look at future trends and practical case studies. I will leave plenty of time for questions and open discussion at the end. Objectives mm, by the end of our session today, I want you to walk away with a deep understanding of the latest AI techniques and how they are applied in healthcare, insight into advanced examples like AI in precision oncology and the newest imaging analysis methods, and awareness of the challenges and ethical dilemmas facing us today. A clear view of future research trends and regulatory um, um, uh, 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 shaping your yeah. My goal is to equip you with a comprehensive perspective on both the promises and complexities, integrating AI in healthcare at the highest level of academia and clinical practices. Why this topic matters? Why this is discussion so timely? Our healthcare system face significant challenges, increasing cost and aging population, and the burden of chronic disease. Simultaneously, we are witnessing the breakthroughs from precision medicine to real-time analysis driven by AI. Um, Advanced algorithms are not only ex, uh, expediting diagnosis and treatment, but also addressing operational inefficiencies with recent developments like integration of large language models like LLM into clinical decision support and advanced robot surgery system. AI is rapidly becoming an indispensable tool in modern medicine. Modern medicine today, we will see how these technologies can make healthcare smarter, faster, and more personalized. Yeah. What is artificial intelligence? When we refer to artificial intelligence or AI, we are talking about system capable of performing tasks that typically require human intelligence. Tasks such as learning, reasoning, and even um, natural language understanding. Today's AI ranges from machine learning algorithm and analyze imaging data to sophisticated neural networks powering conventional agents like the latest generation of ChatGPT. This system have evolved from early rule-based programs to advanced architectures that can process complex multimodal data. This evaluation is crucial for driving breakthroughs in areas such as precision diagnostics and personalized treatment. AI techniques and methods. Let's break down the key techniques driving these advances. Supervised learning, such as much like teaching through examples, models, or trained on annotated data sets. For instance, modern radiology systems use thousands of labeled scans to identify suitable patterns indicative of disease. And then unsupervised learning here, algorithms uncover hidden pattern in unstructured data, a technique that's providing invaluable in genomics, where new genetic makers are still being discovered. Then reinforcement learning. This method teaches system through rewards and penalties. Recent applications include optimizing treatment protocols in simulated environments before clinical trials. Then deep learning using layered neural networks, deep learning as advanced image and speech recognition. A recent example includes CNN and it transforms that analysis and analyze model, medical image, and clinical notes respectively. These techniques are at the heart of innovative solution emerging in our field. What is healthcare? When we say healthcare, we are talking about complex ecosystem that goes well beyond hospitals and doctors. It includes clinical care, administrative operations, research, and public health. In today's data-driven world, we are inundated with information from electronic health records and Here we can say smartwatch and medical imaging to generate and IoT data. The challenge is not only in collecting this data but also in integrating and interpreting it effectively. This is where AI comes into play, enabling us to transform raw data into actionable insight. The intersection of AI and healthcare. This slide illustrates the intersection where AI meets healthcare, imaging a scenario where advanced AI algorithms sift through terabytes of data from EHRs, imaging studies, and wearable devices to identify patterns that inform early diagnosis and personalized treatment plan. For example, researchers are now combining AI with multi-omic data to predict patient response, so a response to therapeutics in oncology. This fusion is technology and healthcare is setting the stage of revolution in how we approach patient care. Historical milestones. Before we get too far into current trends, let's take a quick look back in the early data. In the early days, AI in healthcare was limited to rule-based expert system. Milestones such as IBM Western early venture in oncology and development of computer-aided detection in radiology paved the way of modern AI. Today, we build on these foundations using deep learning and large scale data integration. Each historical breakthrough has contributed to the sophisticated multi-phased AI systems we see today. Uh, Current adoption trends. Today, AI is just a theoretical concept. It's actively used in healthcare institutions around the globe. For instance, leading academic centers are using AI to improve diagnostic accuracy in radiology and pathology. In clinical practice, AI systems are helping predict patient uh, deterioration in intensive care units. We are also seeing um, a partnership between hospitals and tech companies to develop AI-driven solution for administrative tasks. The rapid pace of adoption underscores the transformative potential of AI in our field. Machine learning and deep learning. Let's dive into machine learning and deep learning. Machine learning allows computer to learn patterns from data without explicit programming, while deep learning uses neural network with many layers to process information in a way that mimics the human brain. Consider the latest deep learning models that are being used in radiology to detect early stage lung cancer with a greater accuracy than ever before. These advances are not only reducing diagnostic error but also paving the way of new research in image based disease detection. um, natural language processing, natural language processing or NLP has seen significant advances with emerging large language models like GPT-4 and beyond. In healthcare, NLP is used to mine valuable information from unstructured clinical notes, research articles, and patient communications. For example, NLP systems are now being developed to automatically extract clinical data from electronic health records, helping physician quickly access patient history histories and make informed decision. These advanced models are also stating to support clinical decision support system by summarizing relevant research in real time. For adding this one, okay, I could say our lab developed a probe for cavity-based problems. So if you just scan your cavities, okay, it will generate a complete report within 20 minutes. With that report, you can access any doctors in the world. Okay, so complete scan report. It will also suggest what kind of the problem the patient has and what kind of treatment could be taken in forward. Everything it will give as a report. It is just AI Pro and computer vision. Computer vision is a revolutionizing model imaging. Actually, sorry, the before one we developed that cavity probe. Okay, with the help of industry and institution. Now, few of the local government called district government in Taiwan started using um, in real time within collaboration with the university and in computer vision. Computer vision is revolutionizing medical imaging by using advanced deep learning techniques. Modern computer vision system can interpret and analyze images such as X-rays, MRI, and CT scans with extraordinary accuracy. One cutting edge example is the use of transformer based model and not only detect anomalies in imaging data but also provide explainable visual overlays that highlight areas of concern. This level of sophistication is helping clinicians detect a disease like a cancer earlier than ever before. Robotics and automation. Robotics and automation or transforming surgical procedure and lab workflows. Today, robotic surgical system equipped with AI are assisting surgeon by providing real-time imaging and precision guidance. Advanced system are now capable of performing tasks with sub-millimeter accuracy, reducing complication and improving recovery times. Automation is also streamlining laboratory process from sample handling to automated diagnostic testing, thereby enhancing both speed and accuracy in clinical environment. We heard about IoT. Now it's okay trend for Internet of Medical Things (IoMT). The Internet of Medical Things or IoMT is a rapidly growing network of connected devices, advanced wearable and smart medical devices continuously collect health data, which is then transmitted in real time to cloud-based AI platform for analysis. For example, the latest wearable can monitor patients' cardiovascular health, altering clinicians to irregularities that might indicate early heart failure. This integration of IOMT and AI is not only improving patient monitoring but also enabling a shift towards predictive personalized care. Predictive analysis uses advanced statistical model and machine learning technique to forecast future health events by analyzing historical and real-time data. AI can predict patient risk and disease outbreaks. For instance, some hospitals now use predictive model to identify patients at risk of species, allowing early intervention. Recent advances have improved the accuracy of these predictions by integrating data from diverse sources, including uh, genomics and IOMT devices, making our healthcare responses more predictive. Mm, Genomics and personalized medicine. Genomics is at the forefront of personalized medicine. AI is being used to analyze massive genomic data sets, identifying biomarkers that can predict a patient's risk for diseases such as cancer. Um, with the latest next generation sequencing technique, AI model are now able to provide tailored treatment recommendation based on patients' genetic profile. This approach has already shown promise in precision oncology, where therapies are customized to target the specific mutation found in a tumor. VR and AR, virtual reality and augmented reality, are transforming medical training and surgical planning. VR's simulation allow medical student and surgeon to practice complex procedure in an immersive risk risk-free environment. Meanwhile, AR is being used during surgery to overlay critical information such as patient CT scan data directly into the surgical field. The recent advancement include real-time AR guidance systems that adapt to the surgeon's movement, significantly improving procedural accuracy. Blockchain and data security. With the increasing reliance on digital data, ensuring its security is paramount. Blockchain technology offers a decentralized and tamper-proof way to manage medical records. Advanced blockchain implementations are being um, pil- uh, piloted in several leading healthcare institutions to ensure data integrity and secure patient consent. By using blockchain, we can create a transparent, immutable record of data transactions that not only protect patient privacy but also build trust among clinicians, patients, and regulatory agencies. Emerging AI platform and frameworks. Behind every innovation, AI solution are powerful platform and framework. Today, frameworks such as TensorFlow, PyTorch, and emerging platform like JAX are driving rapid advances in AI research. These tools enable the development of sophisticated models that can process multimodal data, combining imaging, text, and genomic information into unified, actionable insight. Integrating this system with existing clinical workflows, however, remains a challenge that may institution or actively working to solve. Um, Enhanced diagnostic accuracy. One of the most significant contribution of AI is its ability to enhance diagnostic accuracy. Traditional method rely heavily on human interpretation, which can vary between um, Practitioners, advanced AI system now analyze complex data sets and provide objective, um, reproducible results. For example, AI-powered radiology tool or routinely detecting early signs of diseases like lung cancer and diabetic retinopathy, often um, uh, outperforming manual reads. This leads to quicker diagnosis and ultimately um, better patient outcome. Um, early disease detection. Early disease detection is critical for successful treatment, and AI is at the cutting edge of this effort. Modern 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 algorithms can identify minute changes in imaging data, lab results, or even wearable generated matrix that indicate the onset of disease. An existing recent example involves AI system that detect early sign of neurodegenerative disease by analyzing suitable patterns in brain scan long before symptoms appear. Early intervention, as you know, you can be lifesaver. Personalized treatment plan. Personalized treatment uh, is in. Sorry for a minute. Sorry. Personalized treatment plan. Personalized Here, personalized treatment is increasingly become a norm in modern medicine. AI-driven decision support system now integrate patient data ranging from um, genetic information and medical history to lifestyle factors to recommend individualized treatment plan. Um, in advanced oncology centers, these systems have been instrumental in designing targeted therapies that optimize treatment efficiency while minimizing side effects. This personalized approach ensures that each patient receives the best possible care tailored to their unique needs. uh, Drug discovery and development. Drug discovery has traditionally been a lengthy and costly process, but AI is accelerating its dramatically. Today, AI algorithm are sifting through chemical database and simulating molecule interaction to identify um, promising drug candidates in a record time. A recent example is the rapid development of potential therapies during emerging health crisis. Sorry for Thank you. Uh, AI in surgery. In this operating room, AI is providing to be a valuable partner. Robotic surgery system integrating with advanced AI and real-time imaging or assisting surgeons in executing highly precise, minimally invasive procedures. For instance, the latest robotic platform are capable of sub-millimeter accuracy, which um, significantly reduces the complications and accelerates patients' recovery. It's important is to note this system are designed to assist the surgeon, enhancing their skills rather than replacing them. Yeah, remote patient monitoring. Remote patient monitoring is becoming a uh, cons- uh, um, cornerstone of modern healthcare, particularly in managing chronic conditions with advanced IOMT devices and wearables. Patients can continuously track vital signs like heart rate, blood pressure, and the oxygen level from the comfort of their home. These devices are now integrated with AI system that alert healthcare providers when critical changes occur. Recent studies have shown that such monitoring can significantly reduce hospital um, uh, readmission rates and improve overall patient outcomes. Um, yeah, in emergency and critical care. In emergency and critical care, every second counts. AI is transforming how we respond to urgent medical situations. Advanced algorithms analyze real-time patient data to predict which individuals are at risk of rapid deterioration, helping clinicians prioritize care. Some emergency departments are now using AI-enabled um, AI-enabled triad system that optimize resource allocation, ensuring that the most critical case receiving immediate attention. This proactive approach is saving lives in high pressure environments. Case study in radiology. Let's turn into a real world example from radiology in a leading academic hospital. An AI driven imaging tool was implemented to access radiologists in analyzing x-rays and CT scans. This tool uses advanced deep learning algorithms to flag abnormalities and suggest potential diagnosis. The result, uh, that results a significant reduction in diagnostic turnaround times and an improvement in early disease detection rate. This case study exemplifies how integrating AI with the clinical expertise can enhance diagnostic accuracy and efficiency. Same in oncology. Now let's examine a case study in oncology. At a cutting edge cancer center, an AI system was deployed to integrate imaging, um, uh, uh, genomic, and clinical data to develop personalized treatment plan for cancer patient. This system not only recommended targeted therapies but also continuously monitored treatment responses that The outcome were impressive, improved survival rates, reduced side effect, and more precise treatment protocol. This is a prime example of how AI is driving precision medicine in oncology. AI-enabled wearable technologies, advanced wearable technologies are transforming how we manage healthcare on a day-to-day basis. Devices like the latest smartwatches and fitness tracker are now equipped with sensors that continuously monitor vital sign and other health merits. When combined with AI, these devices can detect early warning signs of conditions like uh, atrial fibrillation or sleep apnea, promoting users to seek medical attention. These wearable not only empower individuals to take control of their health, but also provide valuable data that can inform clinical decisions. Uh, Streamlining administrative task. Um, yeah, AI is not only revolutionizing clinical care, it's also streamlining administrative process. Automation tools powered by AI are now handling tasks like scheduling, billing, and managing electronic health records with remarkable efficiency. This reduces the administrative burden on healthcare professionals and minimizes error. Advanced algorithms are being implemented in many institutions to optimize workflows, resulting in significant uh, cost saving and, yeah, smoother patient experience. Improving patient experience. Patient experience is critical, and AI is making significant strides here as well. AI-driven chatbot and virtual assistants are available 24/7 to help uh, patient schedule appointments, answer their queries, and even provide personalized health advice. Recent advancement include chatbots integrated with large language model, which can understand and respond to complex medical queries. These tools improve patient engagement and satisfaction by providing timely, accessible support. Resource optimization. Efficient resource management is essential in any healthcare settings. AI systems are now being used to predict patient inflow and optimize resource allocation from staffing level to bed assignment by forecasting demand based on real-time data and historical trends. Hospitals can ensure that they have the right resource in place at the right time. This not only improve patient care during peak time, but also helps reduce operational costs during slower periods. Data-driven decision making. Data is at the heart of modern healthcare decision making. With the advent of AI, institutions are now integrating diverse data resource, electronic health records, imaging, IOMG, regarding the regardings and even social determination of health um, into one comprehensive system. This data-driven approach allows for more informed strategic decision, whatever it is clinical operation or administrative planning. Advanced analytics are helping leaders identify trends, optimize process, and ultimately improve patient outcomes. AI uh, uh, healthcare research. Research is being transformed by AI as well. Advanced machine learning algorithms are being used to analyze large scale data sets from clinical trial results to genomic sequence, uncovering patterns that would be nearly impossible to detect manually. This has led to faster discoveries and more targeted research efforts. For example, interdisciplinary terms are now using AI to identify novel biomarkers, therapeutic targets in diseases that have long been challenging to treat. Data privacy and security. As we integrate more AI into healthcare, data privacy and security becoming paramount. Patient data is among the most sensitive type of information, and protecting it is a top priority. With advances in encryption, access control, and even blockchain technologies, institutions are working hard to ensure the data remains secure. The recent initiative include multi-factor authentication and advanced monitoring systems designed to detect and prevent data branches, ensuring compliances with standards like HIPAA and GDPR. Bias and fairness in AI algorithm. While AI has enormous potential, we must be mindful of issues like bias. Bias can creep into AI system through unrepresentative training data or flavored algorithm designs, potentially leading to uh, uh, dis- um, disparities in care. It's critical that we continuously audit and update our models using diverse data sets. Recent research has focused on developing fairness aware algorithms that are just for demographic differences, ensuring that all our AI tool deliver equitable care across all populations. Transparency and explainability. Um, one challenge with advanced AI system is that they often work as black boxes. It can be difficult to understand how they reach their conclusions. In healthcare, where every decision matters, transparency is crucial. Technologies like LIME, shape, and the use of interpretable neural networks are being um, developed to open up these black boxes. By making AI decisions more transparent, we can foster trust among clinicians and patients alike, ensuring that these tools are used responsibly. Regulatory and legal challenges. As AI technologies continue to advance, regulatory and legal framework are also evolving. Regulatory bodies such as the FDA are now developing guidelines for AI-driven medical devices and software, ensuring they meet rigorous safety and if efficiency standards. However, the challenges remain, particularly regarding liability if an AI system errs. Determining accountability can be complex. Ongoing collaboration between legal experts, regulatory agencies, and healthcare institutions are essential to navigate these issues and i- is- and um, these issues and protect patient safety while fostering innovations. Ethical concern. Ethics in AI isn't just a theoretical discussion. Um, um, it's a practical necessity. Questions about patient consent, data ownership, and the ethical implications of automated decision making are at the forefront of our work. Many institutions or many institutions are forming a dedicated ethics committee to oversee AI implementation. These bodies help ensure the benefit of AI are realized without compromising patient rights or exacerbating disparities in care. The human AI collaboration. It's important to emphasize that AI is a tool designed to augment human capabilities rather than replace them. The best outcome or the best outcome are achieved when healthcare professionals and AI system work together. For example, an AI might flag a potential diagnosis or recommend a treatment plan, but the um, final decision always rests with a human expert. Um, uh, uh, Already I mentioned that we have developed a probe for cavity. Okay, so the AI will generate a report, and you have to take the report to the nearby hospitals or dentist. So the final decision may be taken by the dentist. So here, just AI will help you to detect what is the problem, because the detecting will okay, the identifying or troubleshooting may vary person to person. Yeah. So addressing the black box issues. Let's take a deeper look at the black box challenge. Advanced techniques such as Lime and Shape are now enabling us to explain AI decision making in un- AI decision making in understandable terms by identifying which features influenced your model's decision. We can provide clinician with the context needed to trust and act on AI recommendation. This transparency is especially important in AI stakes environments, which understanding the reasonable behind the recommendation can be as critical as the recommendation itself. Integration of multimodal data. Looking ahead, one of the most exciting trends is the integration of multimodal data. This means combining data from multiple sources, imaging, genomics, EHR, IOMG devices, into a single unified view of patient health. By merging these diverse data streams, we can develop for more accurate diagnostic tool and personalized treatment plan. Advanced integration technique and data standardization efforts are already underway at a leading research institution promising and new era of comprehensive data-driven healthcare. The AI and personalized medicine evolution. Personalized medicine is transforming how we treat disease. AI allows us to analyze an individual's unique genetic, environmental, and lifestyle data to craft customized treatment uh, customized treatment plans. In AI cutting edge concern, mm, clinicians are now using AI driven tools to predict patient responses to therapies, tailoring treatments in real time. This evolution from a one size fits all uh, model to personalized care not only improves outcomes but also minimize adverse reactions, hurdling a new era in medical practice. Advancement in real-time analysis. Real-time analysis is now possible thanks to advancement in edge computing and high-speed data processing, imaging, and ambulance equipped with AI system that process patient data on the spot or an operating room where real-time analytics guide surgical decisions. These systems are already in uh, pilot phase at some institution, and early results indicate that immediate data-driven decisions can significantly improve outcomes in critical care solution. So, evolution of telemedicine and virtual care. The landscape of healthcare delivery is rapidly evolving with telemedicine and virtual care. With high-speed internet, 5G connectivity, and advanced AI tools. Um, Remote consultation and virtual monitoring are becoming as effective as in-person care. Recent examples include virtual you know, clinics that use AI to assess patient symptoms in real time and direct them to the appropriate care level. This evolution is crucial for expanding access to care, especially in rural and underserved areas. The rise of autonomous system in surgery. Looking toward the future, we are seeing the early emergence of autonomous or semi-autonomous surgical system. This system combine AI, robotics, and real-time imaging to perform highly precise surgical tasks, while fully autonomous surgeries are still in research phase. Advanced robotic systems are already assisting surgeons with tasks that require incredible precision. Early studies suggest that this system can reduce complications and improve recovery times. Yeah, promising sign for future of surgical care. AI in mental health and behavioral analysis. AI is making significant inroads into mental health care as well by using natural language processing and sentiment analysis. Advanced AI system can detect early sign of mental health issues from patient communications, be it emails, text, or social media posts. Digital therapy therapeutics and virtual therapeutic assists are now being developed to provide tailored mental health support. These tools are especially valuable in areas with limited access to traditional mental health service and can help reduce stigma by offering confidential support. Collaborative AI ecosystem. Process in AI is rarely achieved in isolation. The future of AI in healthcare depends on strong collaboration among tech companies, academic institutions, healthcare providers, and regulations by sharing data, expertise, and resource. This collaborative ecosystem drive foster innovation and helps solve complex challenges. Many cutting edge projects today are the result of multi institutional partnership that combine clinical insight with technical expertise, break leading to breakthrough that benefit everyone. Future regulatory landscapes. As AI become a staple in healthcare, a regulatory framework will continue to evolve. Agencies such as the FDA are actively updating guidelines to address the unique challenges posed by AI driven devices and software. Future regulation are likely to be more adaptive, incorporating international standard and real-time monitoring of AI system. This evolving landscape aims to balance the need for innovation with the uh, uh, imperative of patient safety, a challenge that all of us in academia and industry are working together to meet. um, Investment and economic implication. Investment in economic in investment in investment in AI driven healthcare solution has soared in recent year, driven by the promise of significant cost saving, improved efficiencies, and better patient outcomes. Venture capital, government funding, and private investments are fueling a new way of innovation. However, challenges remain such as scalability and addressing funding gaps in public institutions. Understanding these economic impacts helps us appreciate the transformative potential of AI, not just in clinical setting, but across the entire healthcare ecosystem. Yeah, emerging research areas. Yeah, as we conclude this session, mm, I would like to highlight some of the most exciting emerging research area in AI and healthcare. Researchers are exploring quantum computing and pneumographic computing with the promise to revolutionize data processing speeds and model complexity. The next generation explainable AI aims to further demystify complex model and improve clinical trust. This area represents the cutting edge of interdisciplinary research where breakthroughs in computer science, biomedical engineering, and uh, um, clinical practice converge to pave the way for the next generation of healthcare solutions. So, uh, in closing the session, I hope you have gained a comprehensive understanding of both the current landscape and exciting existing future direction in AI and healthcare. We have covered foundational concept, discussed advanced application and challenges, and looked at pioneering example from the field. I am now eager to move on to the question sessions. Thank you for your attention.
Thank you, sir. Thank you for your presentation. Participants, if you have any questions to discuss with the speaker, you can post it in your chat box. Participants, after all the sessions are getting over, you can have the links for taking the test. It will be posted after the third speaker has completed their presentation. Presently, if you have any questions to discuss with the speaker, you can post it in the chat box. Sir, I do not see any questions posted in the chat box. Um, I hope the participants are clear with your presentation. Thank you, sir. Thank you so much for accepting the invitation and given us a nice presentation. Thank you once
Thank,
again.
thank you, thank you. If you have questions, you can mail me also. I will share my mail with the coordinators. Thank you.
Yes, sir. Participants, you can take a short break now. The third speaker will join in another 30 to 35 minutes. So you can take a break and you can join the session at approximately at 4:35 or 4:40. Thank you.
Yeah. Thank you.